Hey everyone, it's Miss Thanafaro again. Today we're going to be learning about Hubble's law and Kepler's law. By the end of this lesson, you should be able to summarize Hubble's law and Kepler's three laws of planetary motion. Before we begin, let's review what a scientific law is. A scientific law is a statement or mathematical expression that describes the behavior of the world. It's based on repeated observations. So last class we talked about scientific theories when we talked about the Big Bang theory and the nebular theory, but today we're talking about laws. So laws are a little different from theories in the way that laws are simply based on repeated observations. So we can see something and we know it's true because we see it multiple times, and we'll call that a fact. And then that kind of ends up being in the same category as a scientific law. Whereas with a theory, we will create hypotheses for our theories and then we can test them and have evidence for them. So let's start with Hubble's law. Hubble's law was created by this guy named Edwin Hubble. So he was an American astronomer. He played a huge role in establishing the fields of extragalactic astronomy and observational cosmology. That just means he studied things in space, like beyond our galaxy, and he studied stars that he could see. And he was considered one of the most important astronomers of all time. So he was responsible for Hubble's law. Hubble's law states that other galaxies are moving away from us, well, away from the Milky Way, which is our galaxy, at a speed that is proportional to their distance. So the further away a galaxy is, the faster it is moving away from us. So that's really important to know. So evidence for Hubble's law is redshifts of galaxies. You may remember redshifts of galaxies from last lesson with Big Bang theory and nebular theory because redshifts of galaxies are also a form of evidence for the Big Bang theory and nebular theory, and it shows up again in Hubble's law. So now we're going to touch on Johannes Kepler. So Johannes Kepler is responsible for Kepler's law. So he was a German astronomer, a mathematician, and astrologer. He was a huge figure in the 17th century scientific revolution. He was best known for his laws of planetary motion, which we'll talk about today. So there are three parts to these laws of planetary motion, but before we begin, let's review some vocabulary. So what is an ellipse? So all planets orbit the sun in the path of an ellipse. So we probably have heard this term maybe from the word elliptical or ellipses. You might have heard it in math, but just to remind you, it's an oval whose shape is determined by 2 points with the figure. So each of these points are called foci. So in science or in astrology and astronomy, more specifically, we're going to talk about these foci as one being the sun and one being our planets. So some ellipses will tend to look like circles, and this happens when there is only one foci point. Okay, so the first part of Kepler's law is the law of ellipsis. So remember, we talked about how our ellipse has two foci. So this picture right here kind of demonstrates this. The sun would be one foci. Our planet, we can say maybe this is Earth, maybe this is Mercury, whatever. This is our second foci. So the law of ellipsis is really simple. It's actually in its own name. So notice ellipsis. The law of ellipsis states that a planet's orbit around the sun is in the shape of an ellipse. So if you have trouble remembering this law, just look at the name. Law of ellipsis, ellipse, in the shape of an ellipse. Okay? So now we're going to talk about Kepler's second law, the law of equal areas. So this law states that planets revolve around the sun at different speeds, at varying speeds. So each planet revolves so that an imaginary line connecting it to the sun sweeps out over equal areas in equal time intervals. So more specifically, with the law of equal areas, it states that when planets are a little closer to the sun, when they revolve around the sun, when they're a little closer, they'll move faster. And they move faster actually because it's a lot closer to the sun. So the sun's gravitational pull is actually causing it to revolve a little faster. And then as it moves further away in its revolution, at this point, it moves slower because the sun's gravitational pull isn't nearly as strong compared to here and here. So this is Kepler's last part of his law, the law of harmonies. So the law of harmonies says that there is a proportional relationship between a planet's orbital period, which is the length of a year, and its distance to the sun. So another easy way to think about this is the further a planet is from the sun, the longer its orbital period will be. So for example, if we look at Jupiter, so the further away we see on this graph, if we look at Mars and Jupiter, let's compare these two. Mars is much closer to the sun than Jupiter. And you'll see that the further away you go, the longer the orbital period is if you look at the x-axis compared to the y-axis. Okay? So let's just quickly review. There are three parts of Kepler's laws. The first law is the law of ellipses. The second law is the law of equal areas, and the third law is the law of harmonies. We also learned about Hubble's law today, which stated that galaxies are moving away from us, or the Milky Way, at a speed that is proportional to their distance. So really quickly, let's do a little checkpoint. Which of the following is true about the planets in the solar system? A, all planets complete one revolution about every 365 days. B, all planets have one moon. C, all planets have an elliptical orbit. Or D, all planets have the same surface temperature. So take a few seconds to think about this question. If you said the answer C, all planets have an elliptical orbit, you're correct. So this goes back to our Kepler's first law, which is the law of ellipses, which stated that a planet's orbit around the sun is in the shape of an ellipse. Okay, so at this time, that's it for Hubble's law and Kepler's law. Please make sure that you complete your exit ticket at the end of this lesson, in addition to completing your guided notes. Thanks, everyone. Bye.